Hello students, once again recapitulation of the topics. After doing so much revision of fourth chapter, linear equations in one variable. Now I would like to move towards a new chapter, that is congruence triangles, chapter 7th of your NCERT book, and it also a very scoring important chapter. You have to understand it well by doing revision with me. So let's start. Okay, here in this chapter, what we deal with some fundamental concept of geometry, which are called as congruence, and the property which enables it are known as congruency. Right? The property is called as congruency, and the concept is congruence. Now, actually, what it means? Congruence of line segments means any given two line segments are said to be congruent if their length are equal, or two line segments say AB and CD. I drawn for you here. AB and CD are congruent when if and only if AB equal to CD. Right? When the length of the line segments become just equal to each other, then we say those two line segments actually congruent to each other. Write the if you take the example, then I will take the example here. Stop you here and take the example that do you see the pages of your notebooks, copies page? All are congruent to each other. Why? Because they covered each other. They are superimposed each other. Right? When something is superimposed each other, when covers whole from the whole corner from the whole side, then we say those two figures or those two objects are congruent to each other. Understand? Now, congruency of angles. Congruence of angles, how? Two angles are congruent if and only if their measures are equal. Again, with the help of protractor, suppose you check the measurement of the angles. When they come equal in measurement, then we say okay, angles are also congruence. Or two angles, say angle BAC and ED, if we named them and draw the figure like this, here I draw for you like ABC and EDF, then their measures of angle BAC comes equal to measures of angle EDF, then we say these two angles are congruent. Right? They are congruent to each other, and the word can be used as congruence of angles. Now, congruence of triangles among triangles, how we can prove? When two triangles are said to be congruent if and only if there is a correspondence between their vertices, such that their corresponding sides, remember the word is corresponding side, means like here if you see the figure AB having its corresponding side as DE in that manner. Okay, means on these they are looking like similar. Corresponding sides and corresponding angles of two triangles are equal or congruent, then we say these two triangles are congruent. Right? If their corresponding sides and their corresponding angles are equal in measure, then we say these two triangles are also congruent to each other. Right? Or it can be proved in this manner that two triangles, suppose ABC, I drawn for you here, the two triangles ABC and DEF, I suppose here for you, are congruent if and only if all these three sides, AB corresponding to DE, AC corresponding to DF, BC corresponding to EF, right? All three sides and angles of one triangle, angles also, angle A become equal to angle D, angle B becomes equal to angle E, C angle become equal to angle F, are equal to the corresponding sides and angles of the other triangle, which means that these two triangles are congruent. Now we have a special significance, or you can say a symbol for congruence is in this manner. This symbol how we show the congruency among the triangles. First you draw the parallel lines, or you can say equality sign, and on the equality side you draw like this similar sign, then it is a sign for congruency, right? Here I written at your right hand side also something, note it down, where AB equals to D, the side, the measurement of side AB equal to DE, BC equal to EF, CA become equal to FD, angle A equal to angle D, they all are corresponding actually. Angle B equal to angle E, angle C equal to angle F, means we have to see angles in such a manner they should be congruence, this should be corresponds to each other, means like they never say that angle C equal to angle C, they are not corresponding angles. Angle C is correspondence to angle F, right? Similarly angle B is the corresponding angle of angle B is this one, angle E. Okay, so remember this point. Now somewhere in book also, NCERT book, and when you're doing the question you see there is a abbreviation used CPCT. That what is the full form of this CPCT? Its full form is corresponding pairs of congruent triangles. When we prove any two triangles are congruent, then we are able to say about their sides, about their angles, then the corresponding parts like angle A, angle B, and AB, or this DE, their corresponding parts, right? So which means if two triangles are proved congruent, then their corresponding parts are also become equals. When we proved and that these two triangles are congruent, then you are able to say the other some parts which are left are also become equal. Now what is the criteria? What is the criteria to prove the triangles to be congruent? There are some 5 criterions we have in our syllabus. The criteria for congruence of triangles. First one, SAS, ASA, AAS, triple S, RHS. Now what are the full form of these abbreviations? SAS, these are short forms. So first one is side and side, angle, side. Next one is angle, side, angle. Third one is angle, angle, side, and then last second is side, 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 and last one is right angle hypotenuse any side, right angle hypotenuse and any side other. So these are the full forms, and how we have to use. First of all, we understand the meaning of this SAS congruency rule, then we apply it. Okay, two triangles are said to be congruent if two sides and the included angle of one are equal to the corresponding sides of and included angle of the other triangle. Means to say, like suppose we take the example of this these two triangles I already drawn for you here. Then it means if suppose you want to say that AB equal to D, and then in second line you say that AC equal to DF. So it must be there the angle included by these two sides. Means you are then talking about these two angles, angle A, angle D. Then never say that if AB equal to means DE and AC equal to DF, and you say that okay angle C is also equal to angle F. Then it's not SAS. SAS means side. What mean of SAS? SAS means when you select any side, then must be its continuous angle and then the continuing sides. Then it become SAS, side angle side. Otherwise not. Included angle must be there. Then we are able to apply this rule SAS. Understand? Remember this point.
Okay, students, there is one more important theorem from your NCERT book and from your syllabus also. It is in this manner that angles opposite to two equal sides of a triangle are equal. What is given? Angles opposite to two equal sides like AB and AC in the given figure. Then the angles opposite to these. Which angle is opposite to AB? Angle C. And which angle is opposite to AC? Angle B. So we have to prove here that angles which are opposite to two equal sides, they are also equal to each other. So let me see how we have to do this theorem to be proved. Okay, what is given to us here? That AB equal to AC is given to us here, right, in triangle ABC, and we have to prove what? That the measurement of angle C should be equal to measurement of angle B, right? Since no any more hint is given to us here, so we go with the help of construction. We do one construction here, that we draw the bisector AD of angle A. Bisector, which divide any line segment or any angle in two equal parts. Here AD behave as a bisector for this angle A, means its small parts become equal then, right? And it meets BC in D point here. So might be D is the midpoint. Let me see how we have to prove. Okay. Proof. In triangle ABD and ACD, we have that AB equals to AC already given. Second, angle BAD equal to angle CAD, because we have done a construction that is AD which bisect angle A. So hence angle BAD equal to angle CAD. These are the small angles of this big angle A, right? Small angles, small parts. They are also equal. Third one, AD is the common side which behave as a commonly in both the triangles. So it is a common side. AD equals to DA, means it is a common side between two triangles. So the three main points are coming here. By looking those, we conclude that the triangles ABD is congruent to triangle ACD. Is a sign of congruency, very well. Now which rule actually we applied here? First of all, we proved that this side is equal, hai. After that, we also proved one of the angle, and then we proved this side. Now look at this triangular figure once again very carefully. One side included angle and second side. It means we applied here SAS rule. We followed SAS congruency axiom here. So by this rule, we are able to say that yes, these two triangles are congruent. And what we required at the end, with the help of our CPCT, CPCT, what? Corresponding parts of congruent triangles. Yes. So by looking at CPCT, we are able to say yes, AB now angle B equal to angle C, and hence it proved that angles, these ABC, this BC is what? These B and C angles are opposite to equal side, means AB and AC of a triangle, and also become equal at the end. So hence it is proved here. I think you understand well. Try to listen video once again to grasp the main point in your mind. Okay, students, now look at here a very nice question from your NCERT book I selected. Here we are applying this rule, SAS rule. So application of rule is there. Now how we applied, let us understand with the help of this question. Okay, a question in this manner: from figure given ACBD is a quadrilateral. ACBD is a quadrilateral here, and in which AC is given to us equal to AD. These two sides are given to us equals in measure, and also AB bisect angle A. AB, the line segment AB bisects angle A. Remember, angle A divided into two equal parts. Okay, showing as 1 and 2, showing as angle 1 and angle 2. Now we have to prove here that show that triangle ABC is congruent to triangle ABD. Triangle ABC congruent to triangle ABD, and also BC equals to BD at the end. BC equal to BD we have to also prove here. Now look at the solution. In these two triangles, say ABC and triangle ABD, AC is equal to AD given to us, right? This is the already thing is given to us. Catch the given things first. AB equals to BA is common in both the triangle. Look at the side AB, then you observe that AB is coming common between these two triangles. Okay. Third one, angle 1 is also coming equal to angle 2, because we already said that AB is a bisector, hence angle A divided into two equal parts, right? Yes or no? Now, by looking these three criterions, we are able to say that triangle ABC is congruent to triangle ABD. Why? Because we applied here SAS rule, side angle side. Okay, side angle side rule. Now with the help of CPCT, because already we have triangles which are congruent, now by taking their corresponding parts, they must be equal. So BC become equal to BD. So both parts now proved here. First one, triangle become congruent, and with the help of congruency, we said that BC is also equal to BD. Hence it proved, right? Students, look at this one more question for the understand of SAS rule. Look at here in this question, the two triangles are given to us. say triangle ABC, triangle DEF, in which something is given to you already, right? Something is given to us, and with the help of that given information, we have to reach till up our motive. What is our motive? To prove them congruent. To prove these two triangles should be congruent to each other. Now, what is given to us in this triangle? Triangle ABC and triangle DEF, angle B equal to E is given to us, angle C equal to angle F is given to us, and also BC equal to EF is given to us. Already we done one theorem, if you remember. If angles are equal of two triangle, then their opposite side must be equal. So, okay, it means if C and F are given to us equal, so measurement of this AB and DE also become equal, right? By using this information, now let me proceed. Consider triangle ABC and triangle DEF, in which AB equals to D. Already I told you now that AB equal to D first thing, and then angle B equal to angle E also given to us, right? And already BC equal to EF is given to us here. BC equal to EF. So which rule is applied actually here? Side, this common angle, included angle, and this side. So it is called SAS rule. Hence, with the help of this SAS rule of congruency, we are now at conclude at the end that these two triangles are congruent to each other. It is a very good use of the rule here for this question. So revise it once again. Yes, one more question I selected for you to understand the SS rule very well. This is a question in which it is in this manner that AB is a line segment and L is its perpendicular bisector. Okay. Now, if a point P lies on this L, then you have to show that P is equidistant from both A and B. Means we have to prove that this P lies at equal distance. The measurement of AP and BP should be equal. So how we can do it? Now look at the solution. Let M be the midpoint of this side AB. Let me suppose that M is that midpoint on AB, right? Now note that L passes through M. The line L passes through M. What it means? It means in triangle APM and triangle BPM. In triangle APM and PM, these two triangles, PM equal to MP, again common line, both are having this PM, both triangles are having commonly side PM, and also AM equal to BM. Why? Because M is we already suppose as a midpoint of AB, hence midpoint means these half parts are equal, yes or no? Now angle PMA is also equal to PMB. Why? Because it's a perpendicular bisector, means 90 degree. Each measurement is equal to 90 degree. Now what actually we applied here? One angle, the two corresponding sides included angle are coming here equal. Hence angle PMA, hence with the help of this angle PMA equal to PMB equal to 90 degree, we are able to say that triangle APM is become congruent to triangle BPM, right? Which rule is applied here? SAS rule once again applied here. So when the triangles are become congruent, we are able to say at the final state that AP equals to PB, which we want actually. AP become equal to PB by CP/CT, corresponding parts of congruent triangles. Hence, P is now equidistant from A and B, and now it is proved. So in this manner, you are able to prove as many as questions by applying SAS rule on different condition, that how we have proved that triangles be congruent to each other, right? So try it again once again on your rough notebook.
Okay, kids, now look at here in this section. Here also we discuss about one more congruency rule among triangles. The rule is AAS, angle side congruence rule, right? In this, two triangles are congruent if and only if any two angles and a side of one triangle are equal. Means any two angles and sides are equal to two angles and the corresponding side of the other, then we say these two triangles are congruent to each other, right? Now look at here how. Given angle A equals to angle D, angle B equals to angle E, angle A equals to angle D, and angle B equals to angle E here, right? And also one of the measurement of the corresponding side like BC and EF, BC and EF are also given to us equal here. Now we have to prove that these two triangles are congruent. Which one? Triangle ABC and triangle DEF are congruent to each other. Now prove. Angle A equals to angle D given to us, angle B is equal to angle E also given to us. Now from these two conditions 1 and 2, we get conclusion that already we know that angle A plus angle B plus angle C equal to 180 degree. How? It is a angle sum property among triangles, right? And on transpose the sum of those two triangle A and B, on right hand side we get angle C equal to 180 minus angle A plus angle B. And already you said angle A equal to angle D there, angle B equal to angle E there. That's why you can replace angle A plus B with angle D plus angle E here, right? And hence we conclude that angle C now become equal to angle F. Why? Because 180 minus D, sum of D and E is equal to angle F. So angle C comes equal to angle F also. Now all three angles coming equal in our hand now, right? Now in triangle ABC and DE, once again angle B equal to angle E, angle C equal to angle F. Now we get it. And also one pair of one side, that is BC equal to EF, is equal. So here by using this rule that angle side angle, or which rule we applied here, because C become equal, B already equal, and the side which is in between these two angles B and C are coming equal. So that's hence by ASA rule you can say the triangles are congruent to each other, triangle ABC and triangle DAF, right? Hence, two triangles are said to be congruent if any two angles and the side of one triangle are equal to two angles and the corresponding side of the other triangle. Note, students, it is not be sufficient that if all three angles of any triangle become equal to all corresponding angles of the other triangle, then they must be congruent. No, it is not sufficient condition. So we never say that triple A is a criterion for to prove the congruency between triangles. So we remember this point, they never be used triple A, right?
Okay, kids, as we proved earlier in one of the theorem that angles which are opposite to equal sides are equal. Now here is a converse of same theorem. If two angles of a triangle are equal, they are given to us, they are equal, then the sides opposite to these equal angle are also equal. The sides, corresponding sides which are opposite to these angles are also equal. Means to say, if this angle B and this angle C are given to us equal, then opposite side of angle B is AC and opposite side of angle C is AB, they also be equal. Now we have to prove this thing here, right? Let me go further. It is given to us that ABC is triangle in which angle B equal to angle C is given to us. Angle B equal to angle C is given to us, right? And we have to prove that AB equal to AC, that the measurement of these two sides AB and AC should be equal. Now again, no more hint is given to us, so let me take help of construction. Now what is the construction? From point A, you have to draw AD in such a manner that it is perpendicular, actually it is perpendicular on BC. So let me start our proof solution. Consider these two triangles ADB and ADC. Always take 90-degree angle at the mid of the arms, right? When we naming the triangle, right angle triangle, so name like this: triangle ADB and ADC, right? In these two triangles, you see both already this is given to us at angle B equal to angle C, right? Also ADB has a common side between these two triangles, AD equal to DA now. And remember, since here we see 90-degree angle is in common measurement, so we say that angle ADB, ADC both are equal to 90-degree in measure. Why? Because already by construction we already use that AD is a perpendicular on BC, right, in construction work. So now which type of three things are used here, which types of criteria we use here, that triangles are congruent now. Therefore triangle ADB become congruent to triangle ADC by applying AAS rule, angle side rule. By following AAS rule, we have done that triangle ADB become congruent to triangle ADC. Since now we have congruent triangles, so we are able to say the respective corresponding parts are also, what are those, that AC is also equal to AB now. So hence what we have to prove, we proved here now that the opposite sides of those two angles are also equal. So this is the converse of the previous theorem. Do it again, once again, revise it thoroughly by seeing the video once again, and note it down in your notebook also. Okay. Okay, here I select from NCERT book one of the good, unique and important question in this manner, that from given figure draw here, if AB parallel to DC, this line is parallel to this line, AB parallel to DC, and P is the midpoint of AC, it means P point is given to us as a midpoint here, right? You have to prove now that P is also the midpoint of BD, that P is also the midpoint of BD. BD is, where is BD? This is the BD. We have to prove P is also midpoint. Means we actually indirectly we have to prove that DP, measurement of DP equal to PB, right? But measurement of this half portion DP equals to BP. We have to prove this here, right? Since now go towards the solution. Since AB parallel DC is given to us, already AB parallel DC given to us, and AC is a transversal. AC, if you look at AC line, it behaves like a transversal between these two parallel lines. Then we are able to say that angle PAB, this angle PAB is equal to angle PCD, this much. Now look at very carefully why they are equal. They are actually alternate angles. Remember alternate angle? They are alternate angles. Okay. Also, AB parallel DC, it means BD is transfer, then angle ABP. Look at ABP now. ABP, this angle is also equal to PDC, this angle. Again, alternate angle, right? Alternate angles of the considered triangles. Here then also you look at that P is the midpoint is given to us, though, so we are able to say that CP equal to PA. CP, where is CP? CP equal to PA, because P is behave as a midpoint already given in the question, right? So by these main three points, and one more thing come here, that one point is also here, that angle DPC, this one is equal to angle APB, this one. Both are vertically opposite angles, right? So by these main conclusion, we coming at the end that triangle DPC is congruent to triangle ABP. Now tell me from your side which rule is actually applied here. Which rule will be applied here? Anybody? Yes, included angle. One side we proved, the second side we have to take to prove. We take the help of the angle actually, not of the side. So what we conclude? AS or AAS. I think AAS. AAS, angle side. We use angle side rule here, and able to prove that these two triangles DPC and APP are congruent to each other, right? So after this, so look at here, since triangle DPC is given to us congruent to triangle ABP by applying AAS rule, thus DP, the segment DP become equal to PB by CPCT once again, right? Hence we proved here that P is the midpoint of that BD. P is the midpoint of that BD. Actually we have to be proved this thing. So we are able to prove now here, right? So do it again in your notebook very nicely, how we proved this thing, and try to revise once again.